hear me? Yeah? Great. I'm Elma Kappa, Operational Lead of Xylem Innovation Labs, and I'm particularly excited for the session we have in store for you today. Xylem Innovation Labs is a team that is mandated to identify and leverage new technologies and support Xylem in our mission to create a more secure world. You will hear more about Xylem Innovation Labs and our mandate from one of our judges soon. Let me quickly explain to you how we will run this session today and also how the audience can be part of it and participate. At Xylem, actually, we talked today about innovation, and how Xylem fosters innovation, and what best way to do so, to show you this, than having our companies to pitch their technology. So I will have been joined here soon on the stage by the 4 out of 13 companies that are this year part of Xylem Innovation Labs Accelerator and Incubator program. But before we move to their pitches, I would like to invite our judges to join me here on the stage. I will ask a question to them. They will be able to ask a few questions to the companies when they pitch. And at the end, they will share what the best pitch of today is. To make this more exciting, we would also like to share or ask you if you'd like to vote your company that you most liked today. So we will share the link at the end of the presentations and you will be able to vote as well. I hope you enjoy and have fun. We don't have a lot of time and we want to dedicate the time for our company, so I'll move from here ahead. Eric Driessen, he's a managing director of Wie Utility for Northern Europe. Eric is a chemical engineer by educational background and has worked for a few innovation startups previously, Norwich, Filtrix and Voltea. Wie Utility is a partner of Xylem. It's a global operating consulting company with fördert scientists and engineers on the market. Eric has been in the water space more than 18 years. Have I done this correctly, Eric? Well, if I haven't, say I did. Xylem is partnering with Wie on one of the innovative approach they did actually recently was to launch the trial Reservoir program, which is changing the way how we pilot and how we actually give funds for pilots. So it allows the startups or companies that want to show their technology to use the central funds and have this financing for upfront costs when they're pilot. And actually, few of our companies in the Accelerator program are in the list to be part of this trial Reservoir. So Eric, I have a question for you. Water is one of the most precious resources, and we at Xylem are focused to try to solve one of the most pressing issues for our customers. From your experience, what can you say about water-related innovations and why this is important that we collectively push for it?
Thanks, Alma, for that introduction. I take this one off. So obviously innovation is super important. It's critical, and especially for the challenges where we stand for today, like droughts, floodings, and new contaminations that we find in water. And so I'm from the Netherlands. I left yesterday from Amsterdam Airport, and always when you land at Amsterdam Airport, the only thing you see is water. So like you think water is in abundance in the Netherlands, but even in the Netherlands we are facing droughts now that we have never seen before. So those droughts need to be tackled with innovation. So innovation is critical, I would say, to solve today's and future problems. But I think even more important than innovation is adoption of innovation. I think innovation will happen naturally because people want to improve, want to do things better. Needs adoption of technology, so we need end users, industry, test technologies, pilot technologies, but also fail and give it another try later on. So yes, innovation is critical for now and the future, but adoption of innovation is even more critical. Thanks, Alma.
Thank you. Thank you, Eric. Georg, hi. So Georg Schoenking is a research analyst at BlueTech. I apologize if I misspelled your surname, Georg.
No problem.
So Georg is a water technology market analyst, and by educational background, he's an environmental and mechanical engineer. Yes, sorry. And BlueTech is another partner of Xylem, who is the leader of market intelligence in the water space. Georg, previously joining BlueTech, worked on research for the membrane desalination at the MIT in the US. But BlueTech insights and analysis are the keys for Xylem Innovation Labs partnership analysis as well. So Georg, we hear a lot talk about technology assessment, insights reports, research projects. So can you tell us more about that from your experience and working at BlueTech?
Sure, yeah. I think one of the key aspects for providing actionable intelligence, which is what BlueTech strives to do, is to actually talk with the end users and with, all of the involved partners that could have a connection point to a given technology. BlueTech started off by profiling individual startup companies. This event today is very close to the origin of the company and has sort of grown from that to produce more macro level insight reports, as well as also delve into our second area of expertise, which is more bespoke consulting services. To answer your question, it's always important to look at the needs of the people that you're talking to, which is why our insight reports also always feature a C-suite section where we summarize the findings from the report for R&D managers, CTOs, and CEOs, as well as people from the investment and M&A space. And I think that would be the key focus for us.
Thank you. Thanks, Georg. And last but not least, a colleague, Max Storto. He's a technology assessment and scouting lead for Xylem Innovation Labs. Max tracks and ensure that we properly look into the potential opportunities in partnership with startups and manage our open innovation ecosystem. Max, tell us more about this, how Xylem fosters innovation.
Absolutely, I'm happy to take a stab at it. And the first thing I'll say is that innovation happens all across Xylem. The innovation labs, as Elma alluded to earlier, really what we're focusing on is how do we create partnerships with external actors, because there's a lot of amazing innovation that's happening externally, and we want to leverage those relationships to complement the sensational research and development work and product development work that Xylem is already doing with a number of our different products. And we don't really do that alone. If you think about where Xylem fits in the kind of innovation space, as a corporate, we have a number of direct channels to customers, and we have expertise in what the customer needs and what clients want. And what we hope to do is work with folks like Sean and Knut, and Lucia and Lorenzo, who's also just a second or two late, to work with all of these amazing technologists and amazing startups to help kind of amplify their work to connect to our end client base and use some of their technologies to both improve what our existing product suite looks like, but also fill gaps that we don't have in our portfolio at all. And the way that we kind of manage that, it's not just as easy or transactional as just talking to the startups, because there's a lot of different experts like Isle here or BlueTech that really understand what the ecosystem is in ways that we couldn't do that on our own. So we kind of create this like complicated web of talking to BlueTech when we need to look at the innovation tracker and understand like a very quick deep dive in what's happening from the innovation side. Or we talk to Isle because we have a great partnership with them that Elma talked to earlier with the trial Reservoir to help alleviate some of the kind of frictions to accessing early stage pilot funding with the trial Reservoir program that's really sensational. And just kind of using their expertise in what utilities need and want. And I think that for us, like in some ways I feel like I'm just like a puzzle piece master. I just put all of the different groups together and talk to the Xylem customer facing folks to understand what we need and what they're seeing, and then talk to everyone else to see kind of what is on the ground, and just kind of making sure that all those folks talk to each other is how innovation happens sometimes. It's not just let's take a technology and then just like put it right, it's ready to deploy, because as Eric said, it's really like growing the technology and technology adoption and innovation adoption that is the challenge.
Thank you, Max. And thanks for our judges.
And now for the everybody. You don't need to hear us talk anymore.
And they will, at the end, select the best pitch of today. Of course, we are not judging technologies, they're all unique, but we rather the way they are presenting that to us as the audience. So the first we would like to start with is EUMap. I will share the link for the audience voting at the end of all the presentations. So, Knut, please. So Knut Hartmann is the Chief Operational Officer of EUMap. Knut is an Earth observation analyst by passion and profession. I loved this when I read the new sentence. Knut joined the EUMap in 2006 when it was a startup at an early phase. Previously, he worked for different research and development firms and holds the PhD in natural science. The stage is yours.
Thank you very much, Elma. And also thank you for being part of this awesome innovation program and for being part of the session. So I have a couple of slides, and I just have to directly push you into our world, which is anything from space down to the surface waters, as you will see. And at the end, I will give a bit of introduction to who EUMap is. Let's start really with the topic of space. So the title is called Water Quality Data from Space. So we are using satellite data to observe surface waters. And I'll give you the introduction here now. So the challenge which we have is of sampling surface data. It's a very local one. It's very intensive in terms of labor and equipment, as you all know. And there are so many surface waters all over the world. It's almost impossible to survey and analyze all those waters. So there is a demand to do that, to observe single ponds, to observe reservoirs over time, over space, just to improve the decisions on managing those assets. So why do we want to do this? I described it here. We want to have a spatial or holistic approach to understand surface waters. So these are just a couple of pictures which illustrate why that is important with this kind of surface waters which we can observe. We can understand algae blooms, we can see dredging turbidity, we can see sedimentation rates. All of that is in satellite data, and you will see a bit of that later on. So let's just understand and dream about the best possible solution. So let's assume there's data, there's information for surface waters everywhere. Those data are accessible, they are there, they don't cost a lot, and you can even go back 10, 20, 30 years back in the past to establish baseline and understand how the ecological state of a water body, for example, it has been and how it has changed over time. So, and if you're working on different scales, you don't want to have very intensive equipment dependencies here. So the question now is this a dream? Can we bring it closer to reality to make it a fit? And you see here this moving world, that's a view from the satellites which we have to our Earth. And we can do more than just these kind of pictures. We can go down to every single water body on Earth over time and do a couple of analytics which brings us closer to this dream.
So you just
Right on the left-hand
the
side.
seat. Elma will introduce
So
you when you need to go
we
pitch.
develop and we are prototyping
It's a
this
silent
kind of
seminar, so
platform
every
which is
time
called the
you want to listen, when
What
you're
you see
speaking
here is a
yourself,
picture of a web application.
you go-
a web
you gotta be
application
there.
which is accessible just
Might
via
bother
your
you
browser.
when-
It's not just like a beautiful user interface.
Might bother
Behind
you
that,
you
we
hear
have
your own
a
voice,
cloud
and you
process
just put your
which
headset in your
automatically
practice,
accesses, harvests,
and then you speak.
and
But
processes
everybody will
satellite
hear
data.
you. We are anyway
This
around, so
entire
if we
process
notice
is
there's something
scalable
wrong
in
with
the
the
way
sound, we'll let
that
you
we
know.
can run
So
processes
to
for
listen to
reservoirs
this
here
needs to
in
be on channel 1,
Africa,
up and down,
for
and this is the
New York
volume.
City, as
To
for
listen.
Great
Listen
Lakes,
to the
as
questions.
for
And to
any
listen what they're
lake,
presenting
any
now.
coastal area which you can
And
think
go
of.
ahead and sit down here.
It also allows to derive a couple of parameters which are of importance, like chlorophyll, albedones, turbidity, and further information. And you can share this kind of data and products via this web application. And as said, the very strong strength here is the back end as well, where we have direct access to satellite data archives and we can do all the analytics. So this picture illustrates just the power of a time series. So what we see here is just a random point somewhere on the globe which we observe for a period of half a year. So you see the time in the x-axis, and on the epsilon axis you see chlorophyll readings by the satellites. Those are the blue lines. And we also see top sample samplings from the authority that time, which, as you will understand, there are just a few of them all the time. But with satellite data, you can actually increase both the spatial information here, but also the temporal information on your, in this case, on the concentration of chlorophyll. Same is true for other parameters. And again, in the background, you just see an example on how this kind of products visualize in this kind of web application. So the big benefits of what we can bring here now, bringing the satellite data to inland water monitoring, is that the solution is obviously very cost efficient. Yeah? So we can do this by using satellite data which are out there, we can do this rapidly, worldwide, and we can even go back 30 years back in the past and do all these temporal analytics and baseline assessments. So who are we actually? I'm actually from the other side of Munich, so not far away from me. That is where the headquarters of EUMap is. We have some business development offices in Dubai, Indonesia, US, Australia. We are not just doing water quality stuff. There are other topics where we serve marine, coastal, and other industry. And what else do we have there? Yeah, we are doing a strong growth here, especially in the COVID times where people could not go out. They are looking for alternatives, and we are strongly benefiting from all the new capabilities on the cloud, on the satellites which are out there and allow us to do the stuff which we do here. We are about 30 employees now. We are around since 2006, and I pointed out that we increase in personal and turnover. Yeah, so we can skip this. Why do we believe we are good? So we are really enthusiastic, really. We do some good stuff. We are top ranked also by other industry, but I'm around here for a while, so if you want to get an insight about our awesomeness, just grab me later on. Thank you very much.
And now we move with our sorry. Right. Is Eric going to ask a question?
Yeah.
Please.
Thanks, Knut, for that presentation. Really, really nice. And I have maybe 150 questions for you, but I'm just allowed to ask one. So that example that you showed with the graph, where you were comparing your data with the grab samples, where you fitted nicely on the grab samples. So do you think in time, would it, in some regions, can it completely replace manual sampling?
Yep. It still works, you can ask me?
Yes.
Yep. No, that's a good point. Yes, it can actually. What you must have in mind, obviously, if you compare sampling data with satellite data, is that you compare somehow one with the other, which is a bit unfair. So if you do grab sampling, you have a couple of, 100 milliliters of water, which you do analyze in the lab. Whereas with satellite data, you have a bit of different kinds of circumstances. But we see these nice fits actually for areas where we could validate both at the same time in the same place. So we see that the validation which is quite nice, chlorophyll, turbidity, for temperature, for others as well. So we can prove that. We have proved this in various kinds of environments, and it can replace it in this way. But the point with the strings obviously comes in combining those. So we, with satellite data, we cannot measure and answer any questions really. So it needs still on-site samples to measure specific parameters or at different depths actually, which is an additional strength. And thinking ahead, then we can also apply new concepts of machine learning and stuff like that to create more parameters than just the ones we've shown. So it's a very interesting time.
Excellent. Thank you very much. Back to you, Alma.
Thank you. Thanks. The second one we have is SEAS. It will be represented by Lucia Catani. She's a senior R&D manager. She holds a master in civil engineering, and she also has a philosophy doctorate in the technologies for energy and environment. She worked for SEAS since 2014. But before she was an independent researcher and works as a professor at the Applied Physics University in Pavia in Italy. Lucia, welcome, thank you, and the stage is yours.
Thank you to all of you. I'm honored to be here today. SEAS is a Swiss company that is focused on water extraction from air. We've got offices in Europe, United States, and also Arab Emirates, but we provide all over the world tailored solution for water extraction from air. But why water extraction from air? Because water sources are becoming scarce, polluted, and depleted. So, you know that on our planet, water is in a closed cycle, and the atmosphere is a big reservoir of water, and it is estimated that contain almost the same quantity of all the rivers all over the world. So, if we're able to catch a part of such water, we can solve a lot of problems. So, but how we catch the water? The water is contained inside the atmosphere that is continuously filled up by evaporation by means of water condensation. And there are two issues related to water extraction from air. The first one is the quality, the second one is the energy required by the process. And the SEAS addressed both the issue from the beginning by means of tailored water treatments and a smart application of the thermodynamic reverse cycle. You know, we treat a flux of air and we cool down under its dew point in order to grab the water from the atmosphere and the heat that we grab from the air in order to make the condensation we do not dispose inside the environment, as well as the flux of the treated air that is cold and dry. We are able to use them inside the building in order to help existing or new plants. And we are able to produce a range of machines that can produce from tens to 1,000 tons water a day, liters water a day, and we can also address difficult environments such as desert one. But in order to better explain our proficiency, I'm going to depict one of our true experiences. Here we are in Mexico. We installed a machine in Villahermosa, Mexico, on the rooftop. And there, you know, they had water indeed, but it is very polluted. You can't drink water there. And the hotel owners provided for free bottled water to the customer and also tanked water to kitchens in order to be sure that water is safe. On the same time, that have also problems with the LPG boiler that has an efficiency of 70%, and laundries are not provided with air conditioning systems. So we collected data about their requirements and installed an AWA machine, 250, able to produce thousands liters a day, and also to help the heating system and to help the laundry by means of a cold and dry flux of air. So we installed our machine, we connected it to the kitchens, we connected it to the domestic heating system in order to provide heating. We maintained the LPG boiler indeed as a backup, but it never started while we made our tests. So we were able to put on a lot of probes in order to be sure of the behavior of the machine in water making, in heating, and in cooling. And with the help of the owners, we collected data in order to understand the behavior of the machine and to make all the calculation about our experience. So, I said you before that water quality is one of our focus, so we tailored the treatment in order to be sure to provide not only safe water, but good water. The owners decided to catch all the water produced by the machine and use it not only to give, instead of bottled water, also the water for the kitchens and for ice making. So we provided a water treatment able to produce, as I said you before, safe and good water. Excellent water. So, at the end of our experience, we found out that we were able to produce about 2,000 liters a day of drinking water, high quality water. On the other side, as I said before, the hotel is a medium-sized water. We covered all the heating requirements of the hotel, so they never turned on the LPG boiler, and the laundry people were better with the comfort by means of our dry and cold air. So, we collected data, we collected the cost saving due to our contribution, thermal contribution coming from our cycle in order to extract water from air, and we made some economic analysis. We find out that if the machine is applied all over the year, you can have a revenue of about $80,000 a year. So why not? This is the scheme of an integration of our machine. Our machine is integrable with existing plants, but also with new plants, in order to improve the energy efficiency by means of the thermal contributions that I described before to you. If you wanted to give a look to our experience by a video, you have got the link there where the experience is described on site. And if you wanted to go in deep with details, you can read a scientific paper based on our experience. Thank you very much for your kind attention.
Thank you, Lucia. I think that walking through a case study, especially in this context, is so helpful to tell the story, so that was really great. I'd love to kind of take that and go a step further and hear about other client types that you work with and who your ideal client is and who your ideal customer is, like so within that client, because I imagine that there are so many different applications, and as you said, there's links to figure out other applications, but what is SEAS like targeting in terms of its go-to-market strategy, and who are you trying to work with?
Okay, we work whenever the water is needed, of course, and whenever you need it safe, good, and you have not many other sources or sources are too polluted. The best client for us is someone who not only need water, but also energy saving, because as I said before, the better application is something that is integrated in buildings. So, as a matter of fact, we are all facing problem with water. So, we are not focused on countries where there is a well-known scarcity. We're focused on all the countries because, unfortunately, we are all facing water scarcity and also pollution. So, of course, our better application are in buildings where you can employ all the energy contributions and give water. But you can use our machine as an heat pumps beside a water maker, as a sort of a conditioning beside a water maker. So if I say to you, who are our customers? Whenever you need energy, whenever you need water. So it is very widespread. And we are able to make calculations about what our machines are able to do, because we have got a deep study inside of it, and we have got a simulator that can simulate the machine all over the world, and it is based, as you know, the quantity of water inside the air is depicted by means of temperature and relative humidity. We have got 10,000 weather stations connected to our software in such a way we can cover more or less the world and tell how our machine works here and there. So this is our analysis. When someone asks us how the machine behaves, here it is.
Thank you, that was really helpful. Thanks, Lucia. Everyone give her a round of applause.
And now we move to Vortech. Sean. So Sean has focused his PhD on vortex flows and hydraulic infrastructure, to then subsequently develop the company and innovative energy efficient waste treatment solutions. Sean is representing, he's the founder and chief executive officer, but he's more working on the sales and commercial relationships. Of course, also part of the strategy of the company to move its technology further. Please.
Thank you, Alma. It's a pleasure to be here at Ifat 2022 with all of you, and thanks to Xylem for this wonderful opportunity to present at this awesome seminar on innovation. So, Vortech is an Irish-based startup company. We've amassed years of experience and expertise, deep technology expertise in the areas of fluid dynamics, process engineering, and control and automation and product design to develop a brand new platform of technologies that's based on vortex flows to transform wastewater treatment sustainably. And why do we need this transformation in the wastewater industry? Well, globally, the wastewater industry is facing some big pain points, and these are centered around challenges such as population growth, increased volumes of wastewater production, exploding electricity prices recently, stringent discharge regulations, and all this combined with the challenge of aging infrastructure. So we need simple solutions to address these challenges going into the future. Been skipping ahead, apologies. Okay, at the heart of these wastewater treatment challenges globally is the aeration process. And aeration accounts for up to 75% of the treatment plant's electricity. That's about 2% of global electricity usage. And when we engage our partners and our customers, we hear the same pain points come up again and again. These are usually around three key pain points. Number one, how do I safely and efficiently retrofit my existing infrastructure? Number two, how do I keep my maintenance costs low? And number three, how do I maintain high energy efficiency? So we have developed a new class of technology that addresses these pain points head on. This new class of technology is called vortex-powered aeration. And what we do that's different is that instead of bringing air deep into the bottom of activated sludge reactors, we instead now bring water to meet the air at the top of a tank, at the top of an active discharge reactor. We do this using a highly efficient, highly reliable pumping technology, which is the only moving part in the system. Skip ahead again. It's the only moving part in the system, and that pumping technology is highly controllable. And all of the equipment is now accessible above the water line. What this means is that we can carry out retrofits more safely and efficiently. We can significantly reduce maintenance costs, and finally, we can significantly increase energy efficiency. We have demonstrated savings of up to 50% in our previous reference sites, which I'm about to describe now. So far we've reference sites across Ireland and the UK, in both the municipal and in the industrial sector. This is an example of a municipal facility where we're treating population equivalent of up to 4,000 people. This is an example of an industrial facility where we're treating livestock waste from an abattoir of up to 1,400 livestock per week. And finally, this is an example of a retrofit in a dairy industrial plant where the client required a boost of capacity efficiently, and we conducted this installation in 3 days with no downtime of existing plant infrastructure. So what value do we offer to our customers? We can now streamline the design and installation process to improve energy efficiency, to reduce carbon emissions, to reduce maintenance and replacement costs over an extended lifespan. And finally, we do this by keeping the noise low and reduce aerosol generation. In aggregate, this combines to reduce the total life cycle cost of the facility. And we are demonstrating this value proposition at client sites, where sustainable impact has been installed in 10 days as opposed to a month for traditional systems. A 30% on a like-for-like basis reduction in electricity costs with traditional aeration technology, and up to 94,000 kilograms of CO2 reduction at another site. Altogether, we're going to introduce savings at this site over 20 years of £1.56 million. I'd like to thank you for the opportunity again to present. We look forward to partnering with Xylem with developing this technology into the global market. And I'd like to take any questions you have.
Thanks so much. Yeah, that was very interesting. Sort of seeing how the energy consumption of wastewater treatment can be changed through innovation. I was wondering if I think I've heard of vortexes being used for a scale reduction before as well, using cavitation vortexes. Is that an area that you're interested in as well with this technology?
In what application?
Scale removal?
I'm not so familiar with that area. We've used vortices in applications like drop structures, and that aeration process involved in averages is also cavitation damage. I'd like to talk a bit more about that application. That sounds interesting.
Sure, yeah, let's chat afterwards on this.
And last but not least, we have Lorenzo. Lorenzo made for me this very difficult, actually. I'm not really prepared for it. I've removed a few slides, but I'm sure you are going to do and explain very well about our work. So Lorenzo holds a Master's Science Architecture in Environmental Energy space, and he worked 20 years in the sustainable development, building up 2 startups in energy environmental space, as well as Orb. Orb is the one he is going to talk to us today.
Thank you, Elma. Hello, everyone. So my name is Lorenzo Falzerano. I'm the founder and CEO of Orb. We've been focusing the last 6 years on solving one of the challenges for the next century, and that is how do we validate that our water is safe for use and reuse in real time. Over the last decade, there was a 300% increase in water risk events across the top 5 economic sectors. And by 2050, 50% of global GDP will be coming from high water risk areas. That's a $75 trillion exposure risk. and water recycling has become a necessity. Municipals have committed 20% recycling capacity by 2025, and the top commercial brands have said that $300 billion of revenue is at risk from water events, and their main strategy to combat this is water recycling and reuse. And a lot of them are committing to net zero water by 2030. And in buildings, 800% increase in Legionella outbreaks in the last 20 years. They need a better on-site treatment and better monitoring solution. So what's the problem? Well, water recycling is speeding up, but contamination testing, microbial testing is still very slow. It takes 3 days to get a microbial sample result back. In those 3 days, one bacterial cell can double 216 times, ending up, and I had to look up this number, 26 vigintillion cells. That's 10 to the 63 cells. So basically, 3-day-old data can never run a safe and optimized system. We need something better. And that's why, unfortunately, microbes are still the #1 failure reason for water assets globally. In 2020, in the UK water utility space, over 50% of asset failures were due to microbes in nature. And each one of those investigations cost between £5,000 to £45,000. But the big kicker here is that 90% of those investigations find no root cause for those failures. They don't know why those failures are happening, and they're following best practices. Well, why is this? Well, to date, we just don't currently monitor microbes in real time. We use a range of what we call inference monitors or proxies, such as turbidity, temperature, or chlorine, that even if you have zero turbidity in your water, you still have millions of microbial cells below that zero turbidity that can give you great insights into the biostability and the risk of your water. So unfortunately, we're running our world on blind processes. Essentially, how much chlorine or chemicals can we add at this without killing humans? We're doing that, but unfortunately we're still getting failures. And those failures are increasing risk to public health and also cost to our bottom line. But what if we had a better solution that we could monitor those microbes in real time? And that's what Orb has spent the last 6 years doing. This year we'll be launching our Orb Probe, which can detect cell counts in real time, and with the addition of our remote intelligence platform. As easy to use as pushing a button, and as easy to read as a traffic light. You don't need to be a microbiologist or any ologist to use our system. We're delivering high resolution data, going from 3-day-old data to data to up to 1 second if you want. Okay, so what are we doing? What's the magic? We're using a technique that's been known before. It's called precision spectroscopy or fluorescent spectroscopy. What we're essentially doing is we're firing out photons into the water, which are essentially packets of energy. Aromatic compounds, amino acids and proteins in that water absorb that energy, and then they re-emit new photons that our neural nets and our detectors analyze, deconvolute that signature, and we can give a greater understanding of that water. So we're going from, not only are we going from 3-day-old data currently to real-time data, we're going one step further and giving you predictive analytics. Understanding the seasonality and the trend of those microbes that your current telemetry say is zero, understanding those trends, and based on customer thresholds, whatever that customer threshold is, we could then predict that your threshold will be breached in 9 days, 9 hours, and 55 minutes. That's just something that doesn't exist today, until now. So we're outcompeting the nearest competing technologies on many fronts, delivering savings to our customers, reducing risk profile, and getting them to better understand their treatment and their operations. Okay, so how does it work in the real world? We've done 2 years of independent studies with Cranfield University and Anglian Water. This is Stuart Knott. He is a senior optimization engineer, and he's been charged by the board of Anglian Water and the CEO to deliver a smart water network and to make sure that they're not getting any more compliance failures on their network. So how did we help them? We helped them understand impacts to water quality based on changes in their ozone dosing. This peak that you see here was not seen by turbidity or any of the other probes out there. They could then understand precision when to take a regulatory sample to see whether this was a risk event or not. We also help them understand treatment travel times through the system. Again, something that they're blind to right now. Here we're seeing the signal coming from primary and ozone. That is 4 treatment stages further upstream. We're able to see that fingerprint, a special fingerprint of each of those stages and how it's impacting the water quality. Again, to do precision regulatory sampling. And the same thing, when we monitored pre and post chlorine, we were showing them events that were happening post-chlorine, anomalies that weren't there before. Again, helping to understand and optimize their system. So remember earlier I said, or maybe I didn't, 90% of failures find no root cause. For service reservoirs in the distribution network, regulatory requirements are only to monitor once a week on the outlet only. But when we look at this particular service reservoir and we're monitoring the inlet, and this is a 5-minute resolution over 14 days, sorry, this is 60-minute and 5, over 2 weeks, we started to see an increase in the cell counts on the trend going into the service reservoir. Even though this service reservoir looks stable, we're saying, okay, it's acting as a buffer, it was the trunk main feeding it that was having these diurnal fluctuations. What else was interesting is that each one of these major and minor peaks and troughs that you see here actually ties back to another process happening in the network, pumps coming on and offline, filters back flushing, and also service reservoir 10, 15 miles away coming online. So we're able to fingerprint all of those from one sampling point and then tie back a risk evaluation of each one of those treatment processes and which one was feeding a risk to this reservoir. So basically what we're doing is help customers to optimize their system and monitor biostability. If you're looking at maintenance schedules, for example, when to run a maintenance on a high-risk asset rather than blindly or running on a sequential order for your maintenance, and to help customers reduce that risk for the end customer and reduce those costs. And that's why we're happy to say Anglian Water, after 2 years of trials, placed our very first commercial order this year, and we'll be delivering units in Q3 of this year, and then with them and with other strategic customers too. Thank you.
Great presentation. Thank you very much, Lorenzo. We at ISLE also like your technology. We have introduced your technology to many utilities already. So I worked for a water utility 10 years ago, and back then we always said to each other, when we take a sample today, we have the results when the water has already been drunk. So that's something we know for 10, 20, 30 years already. Your solution it's sort of in the category too good to be true, but it is true. Why is your technology not being adopted? Like, why don't you have thousands of orders per day now? It's such a no-brainer that your technology can replace laboratory tests. So my question basically is, how can we increase or accelerate the adoption of your technology at end users? What is the barrier there? Is there a barrier?
So yeah, there's multiple parts to that question. But firstly, we're not launched yet publicly. So these probes will be launched later in this year, Q3. We had a larger system which was 17 inches by what have you. It was a flow cell version. So I think the big friction point here is risk. Okay, risk. Who is this company? How long have they been around? Who are they? Why should we adopt their tech? Can we trust their technology? And it seems that the only people we've got the most traction with are clients that have specific academics or research skill sets in-house that understand the technology. So fluorescence has been around for a long time. What's new with us is with increases in detector sensitivity, advances in LED technology, and now with the democratization of neural nets and AI deep learning, we've been able to combine all of those together to deliver these cell counts. On another level, it's still not known how a cell count ties to an actual risk. So is there an absolute cell count number that ties to a risk for your system? So what we're seeing here is that it's more about monitoring the biostability. So what is the relationship of that grab sample today to what the sample count was yesterday and what is it tomorrow, and building that relationship to understand stability. So we hope, yes, in the future we want to be that go-to technology that is a standard. So we would complement turbidity, chlorine. I think we are the missing link in that online, real-time, cost-effective monitoring solution.
Excellent. Thank you very much.
All right. Thanks, Lawrence. Thanks to all the pitchers so far. So now you get the chance to vote. If you can get close to this QR code, that's the easiest way to do it. or you can also just go to this link up here, and we'll reveal who the audience choice was. But the judges, let's confer really quickly to make sure we're on the same page to see whose pitch we liked the best.
Kommt das Voting noch?
This one there?
Before the next session starts.
What companies? I don't know. I've got a list for you.
All right, so I think we are ready to say how audience found the best pitch for and the judges. So surprisingly or not, they are aligned. So audience and judges voted for the best pitch of today. So again, not technology, the pitch, and it was Orb. Lorenzo, congratulations. And maybe you want to say a few words about that. Thank you.
Yeah, we thought all the pictures were really, really strong, and there were elements that I think everyone can improve because you're always can get better. But I think that there were elements that we can keep, and I'm happy to give feedback to everyone later on. But in particular, Lorenzo, we thought you walked really, really strongly through the customer need, and we could really position ourselves and understand what that challenge is in the sampling challenge and why that delay is so crucial to solve now. And we really liked how it fit into a number of different technologies and different testing methods that it could kind of balance together. You did a really good job of kind of fitting Orb's technology into the entire technology ecosystem. So well done, and well done to everyone, and thank you for participating and for voting. This was really fun, and enjoy the rest of the conference. I would love to talk about Xylem Innovation Labs and the other technologies to anyone who's interested, so feel free to drop by and say hi to me, or to Elma as well. She can touch on that, but thank you so much.
Highlight?